What if the universe isn't advanced, but outdated? What if the cosmic glitches we see, vanishing stars, impossible galaxies, broken physics, aren't mysteries at all, but the signs of a universe running on an old, unstable operating system? Today, we're asking a question almost too ridiculous to take seriously until you hear the evidence. Is the universe running on something that feels suspiciously like Windows 95? For generations, humanity has looked up at the night sky and believed we were staring into perfection, the flawless machinery of the cosmos. But in the last few decades, astronomers have begun seeing things that don't behave, don't compute, and don't follow the rules. Entire stars disappearing without exploding, galaxies older than the universe, regions of space where physics itself simply stops working. These aren't small anomalies. These are glitches, system errors, crashes. And what's even more shocking? The universe behaves as if it's struggling to render reality, the same way an old computer struggles to load a massive file. This is the foundation of simulation theory, the idea that our universe isn't physical at all, but a mathematical construct being processed by something else, something bigger, something with limitations, something not upgraded in a very long time. In this video, we'll explore the real astronomical phenomena that scientists can't explain and reveal why they resemble bugs in a low-resolution simulation. By the end, you'll see the universe not as a majestic clockwork machine, but as a giant cosmic program that might be long overdue for an update. Let's begin. Imagine a place in the universe so empty, so devoid of matter, that it shouldn't exist under the laws of physics. A region where not just stars, not just galaxies, but entire clusters of galaxies are missing, like someone erased them with a cosmic delete tool. This is the Eridanus supervoid, one of the largest, most mysterious empty regions ever discovered. It spans over 1 billion light-years, and no known model of cosmic formation can explain how such a massive gap appeared naturally. If our universe were a simulation, this feels like a classic rendering issue, the equivalent of an open-world video game where a section of the map hasn't fully loaded. Imagine playing a game, and suddenly you find yourself in a giant area with no trees, no buildings, no NPCs, just nothing. Not because the world doesn't include those things, but because your system failed to render them in time. Now compare that to the Eridanus supervoid. It's as if the cosmic renderer simply skipped a region, left it blank, didn't bother populating it. Scientists have tried dozens of theories, collisions with parallel universes, dark energy fluctuations, even the idea that an unknown structure pushed matter aside. But none fit, none explain its size, its shape, its sheer emptiness, unless the universe is not infinite complexity, unless it uses shortcuts, optimizations, areas that aren't meant to be seen or interacted with, receive fewer resources. Just like a video game that only renders what the player is close to, the universe may only render what consciousness observes. And this supervoid? It could be the cosmic equivalent of a chunk that never finished loading, a glitch, a missing texture, a sign that something behind the scenes cut corners. In 2019, astronomers noticed something extraordinary. A massive star, one of the brightest in its region, began to fade. Then it vanished completely. No explosion, no collapse, no debris, nothing. It was simply gone. This wasn't some tiny flicker or a dust cloud passing by. This was a colossal blue giant, millions of times brighter than our sun, and it just blinked out, like a light on a faulty circuit. Scientists first assumed it must have turned into a supernova, but no trace of one could be found. In a physical universe, stars don't simply disappear. They evolve. They die violently. They leave behind scars. But in a simulated universe, objects can disappear when the data behind them is removed. Imagine you're playing a game and walk past a building. You look away, then turn back, and the building is gone. The game's rendering software may have unloaded the asset to save memory, or a bug caused it to despawn. Now consider this star. What if it wasn't following astrophysical rules, but computational ones? Astronomers proposed theories. Maybe it was swallowed by a black hole. Maybe it was obscured by dust. Maybe our instruments glitched. But across multiple telescopes, across multiple months, across multiple wavelengths, there was nothing. It's as if the star's code was deleted from the simulation, and no cleanup script ran to explain the absence. Just a missing line of reality. A cosmic bug, a system hiccup, one that hints our universe is not as stable as we think. When the James Webb Space Telescope began sending back its first images, astronomers expected to find young, small, newly formed galaxies. What they found instead shocked the entire scientific community. They found galaxies that were too massive, too structured, too chemically complex, too old for the era in which they formed. Some appeared 300 to 500 million years after the Big Bang, yet they looked like they had undergone billions of years of evolution. In other words, they shouldn't exist. It's like starting a brand new video game and finding fully built cities, advanced technology, and leveled up characters in the first tutorial zone. Something didn't add up. In a universe governed by physics and time, formation takes billions of years. But in a simulation, objects can be preloaded, generated, inserted. If the Big Bang was the initialization moment, the startup screen, then these galaxies might be prefabricated assets included by the system. Like a world that ships with certain structures already in place, even if the in-game timeline says they shouldn't exist yet. Astronomers are uncomfortable with this. Some blame hidden physics. Some blame faulty models. Some blame unknown formation processes. But none of those explanations feel honest. These galaxies are like finding fossilized cities in the wrong geological layer. Not old mysteries, but misplaced files. A sign the universe is not building itself naturally, but loading pre-generated data. Another glitch, another rendering mistake, another clue. Have you ever wondered why nothing in the universe can move faster than the speed of light, not even by a fraction? Why nature enforces this strict, absolute limit, as if it's part of the code? Simulation theory offers a shocking explanation. The speed of light isn't a physical limit, it's a processing limit. Think of a video game. The world updates frame by frame. You can't move faster than the game can render you. Your maximum speed is locked to prevent the system from breaking. In our universe, light travels at 299,792 kilometers per second. It never changes, never fluctuates, never varies. No other constant in physics is this stubbornly constant. It behaves exactly like a hard-coded speed cap in a simulation. But there's more. Quantum experiments show that reality only renders itself when observed. Unseen particles exist in fuzzy states called superpositions. When you measure them, they lock into a definite position. This is exactly how games conserve memory. They don't render every detail in real time, only what's on screen. Everything else exists in low resolution until the player looks at it. If our universe is running on limited processing power, like a cosmic Windows 95, then the speed of light is the ultimate sign of efficiency, a way to keep the simulation from overloading, a way to cap the frame rate, a way to maintain stability. It's not just a rule of physics, it's a technical safeguard, a boundary placed by the system. And if light is the speed limit, then what else is hard-coded? What other laws of nature are just lines of code in the background? In 2004, scientists mapping the cosmic microwave background, the leftover radiation from the Big Bang, found something bizarre. A huge region of space colder than its surroundings, far colder than should be possible. They called it the cold spot. It's not just a minor temperature dip. It's a massive, anomalous region that spans hundreds of millions of light years. And here's the twist. It overlaps with the Eridanus supervoid. Two impossible phenomena in the same region. The cold spot behaves like a section of the cosmic map where the simulation engine hiccuped, failing to populate matter and failing to assign the correct temperature values. It's the cosmological equivalent of seeing a chunk of terrain in a video game load with the wrong textures. Flat, featureless, incorrect. Scientists suggested maybe it was caused by gravitational lensing or cosmic collisions with alternate universes. But none of those explanations fit. The cold spot looks like a missing resource, a corrupted cache, a rendering bug. The universe is supposed to be uniform on the largest scales, but here, it breaks its own rules. It's as if the system forgot to fill that region with the correct data and just left it blank. Another error, another glitch, another hint that the universe is not perfect, but sloppy. Let's go back to the beginning. The Big Bang should have produced equal amounts of matter and antimatter. That's what the equations demand. That's what the physics predicts. That's what symmetry requires. But in our universe, antimatter is almost completely missing. It's not hidden. It's not locked away. It's not inaccessible. It's just not there. This is one of the biggest unsolved problems in physics. But if our universe is a simulation, this missing antimatter makes perfect sense. Imagine you're designing a complex virtual world. Do you render every particle, every force, every perfect symmetry? Or do you simplify the system? Do you include features that won't matter to gameplay? Full antimatter implementation would double the computational cost of reality. It would require double the storage, double the particle interactions, double the energy. A simple fix? Just remove it, skip it. Hard code matter dominance. Like a developer saying, let's not include all that, it's unnecessary. Our universe behaves not like a perfectly balanced equation, but like an optimized simulation, a simplified build, a streamlined version, a performance-friendly model. In other words, a universe running on old hardware. Because producing and tracking equal antimatter would require more resources the system may not have, this is not a mistake. It's a shortcut, a cheap trick, an optimization. At the smallest possible scale, far beyond atoms, quarks, or quantum strings, there exists something scientists call the Planck length. It is the smallest possible unit of space. You cannot divide it, you cannot go smaller. Space itself becomes pixelated, just like digital images, just like rendered environments, just like video game worlds made of tiny squares. The Planck length is 1.6 times 10 to the negative 35th meters. A number so small, you could fit trillions of these pixels inside a proton. But here's the glitch. If the universe were truly continuous and smooth, there would be no minimum size. Space could be infinitely divided, but it isn't. It's quantized, chunked, broken into discrete units. Reality has a pixel limit. In physics, this is considered mysterious. In a simulation, it is obvious. Every digital environment has a pixel size, the resolution limit. The Planck length is the resolution of the universe. And here's where it gets even more interesting. Light cannot move through space in smaller increments than 1 Planck length per 1 Planck time. Sound familiar? That's a frame rate. Reality updates itself in discrete steps, like clock cycles in a computer. This isn't just a glitch. This is the underlying structure of the simulation, the signature of the rendering engine. We are living in a pixelated universe, masquerading as analog. If any experiment reveals simulation behavior, it's the famous double-slit experiment. Fire a particle at 2 slits. It should pass through one or the other. But when unobserved, it goes through both, and neither, and every possible path simultaneously. A blurry probability wave, a fuzzy, undefined state. But when you observe the particle, when you measure it, it instantly collapses into a single, definite path. This suggests one thing. Reality only becomes real when someone is looking. Just like a simulation engine, just like ray tracing in video games, just like optimization algorithms that render detail only in the player's line of sight. The universe behaves lazily. It doesn't calculate everything unless it has to. It doesn't simulate every photon, every atom, every trajectory, until an observer forces it to. Your consciousness is like a cursor. Where you look, the system loads high-resolution physics. Where you don't, the world is low-resolution and lazily calculated. The double-slit experiment isn't just strange physics. It is the cosmic equivalent of opening a video game's debug menu and discovering how the world is actually built. A simulated universe with rendering on demand. And it begs the question, is the universe observing itself? Or are we the observers forcing the system to update? Because if reality must be observed to exist, who is the system designed for? In 1998, astronomers discovered something terrifying. The universe isn't just expanding, it's expanding faster and faster, as if pushed outward by an invisible force. They named it dark energy. But nobody knows what it is, why it exists, where it comes from, how it works. And here's the glitch. Dark energy behaves like a mathematical patch, a correction added to the equations to stabilize the simulation. Imagine a developer notices that their world simulation is collapsing inward, so they add a constant outward force to prevent everything from crunching together. A failsafe, a global stabilizer. The universe should be slowing down due to gravity, but instead, it accelerates. This is not natural. This is corrective behavior. Like a background process in the engine, a balancing mechanic, a cosmic autopilot kicking in to maintain stability in a system that would otherwise break. If the universe is running on outdated hardware, a cosmic Windows 95, then dark energy may be the equivalent of a memory leak fix, an anti-crash safeguard, a system patch to prevent universal failure. Not a mystery, not a force, but a fix. A sign that the simulation is old, struggling, slowly breaking. If the universe is a simulation, then we must ask, what happens when the system runs out of memory, or reaches its processing limit, or suffers a catastrophic error? Look around. Time itself behaves like a system resource. It flows in one direction, like a write-only memory buffer. It speeds up and slows down depending on gravity, like lag under heavy load. It breaks at singularities, like data corruption. Black holes might not be exotic objects, but memory sinks. End-of-file markers, garbage collection zones. When something falls into a black hole, information is not destroyed, it's relocated, compressed, stored, like the universe clearing RAM. Even more disturbing, the universe appears to be losing energy, cooling, thinning, running down, just like an old machine. Eventually, simulations end. Programs close, systems shut down. Could the phenomenon we call heat death be nothing more than the simulation closing? A shutdown sequence? A halt command? If physics is code, then time is execution. And when execution ends, so does the universe. And here's the most chilling question of all. Will anyone come to restart us? Reboot us? Upgrade us? Patch the glitches? Or will we simply freeze in low-resolution silence forever? We began this journey with a joke, the idea that the universe might be running on Windows 95, But the deeper we look, the less it feels like a joke. The universe is full of missing data, rendering bugs, impossible structures, corrupted regions, missing features, pixelation limits, hard-coded maximum speeds, and objects that appear and disappear without explanation. This is not the behavior of a flawless, perfectly designed reality. This is the behavior of a system with constraints, with shortcuts, with bugs. A system doing its best on limited hardware to maintain the illusion of continuity. So yes, maybe the universe is not running on some divine supercomputer. Maybe it's not a masterpiece of cosmic engineering. Maybe it's just old. And maybe, just maybe, every glitch we see is a reminder that we are living inside a vast, ancient simulation that was never intended to be perfect, not infinite, not omniscient, not divine. Just functional enough, just stable enough. A cosmic operating system held together by duct tape and patches, the greatest mystery in existence, running on the cosmic equivalent of Windows 95. And the real question is not whether the universe is simulated. The real question is, who is running it? And what will they do when it finally crashes?